Alright, so I am going to go over some of the questions here for your test review. Your test will be on Friday, and the test review must be turned in on Friday to get quiz grade, which is 40 points. It's a lot. I'm trying to help you here. So all the problems you're supposed to show me work unless it's multiple choice. Please use your time wisely in class and also watch my video. So question number 5. Select all of the following graph which represent y as a function of x. So here, basically you have graphs, and we know what's a function. The function is every x have a unit y, or you can draw a vertical line test. If the vertical line is interacting with the function only once, everywhere on the function, it's a function. If it intercept with the function several times, more than once, then it's not a function. So for here, all you have to do is to draw the line. Okay, for A, draw the line. Well, there's only one interception anywhere. So A is correct. B, draw the line here, draw the line here. You don't really have to draw the line, you just have to visualize it. B, it will be one line everywhere, so B is correct. C, if I just draw the line here, it has intercept, intercept, intercept more than once, so C is not. D, correct. C, E, correct. F, you draw the line more than once, no. Okay, straightforward. This one is the same idea. It's just different function. So here, check. Here, check. Here, no check. Here, this is tricky, right? If you draw a straight line on the function, it actually every single point well, it is a straight line, so well, we already know that this is a function. It's just x equal 2. Okay, so yes. This straight line, yes. This, no. So those are answer. Okay, let's take a look at number 7, 8, 9, 10. They are all tables. So like I said, every single x should have unique y, only one y. So here, basically if you look at the table, all you have to see is if you all have different x's, it works. If I have multiple same x, it's wrong. So 5, 10, 15. It all have different x, and then that means each x will have its own y. So A is right. B, 5, 10, 15. Even though 10 is 8, 15 is also 8. But 10 has its own 8, 15 has its own 8. So it's a function. But here, C has 210. So 10 is x, right? But x has 1y and 2y. So the 10 does not have a unique y. Okay, so it looks something like this. Okay, you have the same x to the two different y's, so it's not a function. So basically, if you have the same x, that's not a function. So let's just test it out. This is a function, 2, 6, 13. This have 2, 6, not a function. This is a function. Same thing here. It's just vertically x and y. So x is 0, 3, 4, 8, 3. 3 and 1, 3 and 1. Well, they're the same point, right? If it's the same point, that means just one dot, so it is a function. Here, negative 1, 2, 5, 8, 12, all different x, so it's a function. Here we have 2 threes. 3 goes to 1, 3 goes to 4. So it's not, y has two different, or x have two different y, so it's not a function. And here, d, negative 1, 1, 4, 9, 12, all different x, so it's a function. You see where I'm going? Yeah. So work the 10, 11, and 12 out. Well, work the 10 out yourself. The next question is number 15. Number 15, it says, given each function, which is the y, okay? This is the function. Evaluate f1 and function when x is 3. So basically, what it asks you is, what is y when x equal to 1 and when x equal to 3? Very straightforward. So when x equal to 1, go to number 15. X is 1 right here. If you go to the function, it's this dot. This dot, the y is 1. So f1 is 1 for 15. And then for function when x is 3. So 3 is right here. So if you go to 3 to the function, it's this dot. This dot, if you look at the y, is still 1, right? So f3 is still 1. Work on number 16. Well, number 17. Evaluate g parentheses 2. That asks you, so basically whatever g is the y, okay? So it asks you, what is the y when x is 2? So go to x is 2, then go up to the function. Okay, that's the dot, intercept. So what is the y for that dot? It's 4. But b, it tells you the y is 2 already. So basically it tells you y is 2, then what is x? So what you need to do is find the y is 2. 2 is right here, right? Y is 2. Then go to the function. So this is the dot, the y is 2, intercept with the function and go down. You see the x. So x equal negative 3. Right? So there are two different questions. It asks you. One give you y, ask for x. One give you x, ask for y. You got to be careful with that. You can work number 18 out by yourself. So table, even easier. Table, it tells you, okay, evaluate f3. So asks you, what is the y when x is 3? X is 3, y is 53. So when you solve it, when you write your answer, you need to write like this. And this, basically y equal 1, what's x? Okay? Find it out yourself. You can work on number 20. And the next one is 21 and 27. So I did not give you a lot of questions to work on, but your test will come out any one of those. It's not going to be too much calculation, I promise. You can use a calculator as well. So number 21. Okay, so all you have to do is find out what's the y if x are all 5 digits number. So I'm going to demonstrate 21. So 21, fx is 4 minus 2x. So what is the x is negative 2? All you have to do, plug in the negative 2, replace the x with negative 2, and find the answer. The next one is negative 1. So same equation, just plug in different number. Okay, so on and so forth. 27, same idea. 27, fx is 3 plus root x plus 3. So your f negative 2 will be 3 plus root negative 2. Replace the x with negative 2 plus 3. Do the math inside of the root first. You get 3 plus root 1. Root 1 is 1. You have a 4. And then you have to work out the next 4 questions. So let's move on to another section with domain and range. 31, 32. So one thing about domain is x. So that's horizontally, you look at left and right, right? And range is y, you look at up and down. So write your internal notation. Question number 1. Domain, left and right. So you always start with the most left part. So what's the most left part? It's negative 5. And then we have a solid dot. Solid dot means the negative 5 is included. So negative 5. Bracket means included. Then go all the way to the right. The right end as 3. And 3 has a hollow dot. Hollow dot means the 3 is not included. So 3 parentheses. That's a domain. And the range, up and down. Up and down. What is the lowest point? Going from the low to high, okay? What's the lowest point? Right here. Lowest point, you look at the y-axis. Y is right here, up and down. So the lowest is 0, and then you actually touch the 0. So it's bracket 0, and then go all the way to the 2. The 2, because this dot on the left is actually solid. So the solid dot means that this y is included. So 2 is also included. So that's a 2 bracket. What about number 2? Number 2, let's look at domain. Domain is left and right. From the left, x-axis, it starts at negative 3. Since it's a solid dot, it's negative 3, bracket. Then it ends at 2, but it's a hollow dot, so it's a parentheses. What about range? Range going up and down. So go from the low, go up. Low as negative 5. So it's also a solid dot, so it's negative 5, bracket. And going all the way, the highest point is at 4. It touched the 4, so it's also 4 bracket. Okay? Don't worry about 3 and 4. Just skip 3 and 4 because we did not talk about inequality in the class for domain range. Let's just skip that. So let's look at domain. So domain, what's a domain when you have an equation? Domain usually, so when you have a function, okay, it's usually something like this, okay? So if you look at those, domain usually is going from the negative infinity to infinity. However, there could be some point that cannot be included. Okay, so for example, this dot cannot be included. So you will have negative infinity all the way to where the dot is, like the 1. Okay, it's not included. Then going from 1 to positive infinity. We saw something like that in class. So we just have to figure out what the x is not. Does not, well, where x cannot be, then exclude that point. So number 7. Number 7, what you have here is a square root. Square root can only root a positive number or 0. So that means whatever number inside the root must be larger or equal to 0, or minus 2 cannot be, cannot less than 2. Okay? It's more like that. So let's just use the first one. So x minus 2 must be larger and equal to 0. So if you solve it, x is larger and equal to 2. So when you write your notation, remember how we write the notation here? X is larger and equal to 2. So we have a number 2, right? Number 2 is a smaller number. And then it's equal, so it's bracket on the left side. And then x is bigger than 2, so x go all the way to the right. Go all the way to the right to the infinity is a positive infinity. So that is your domain. Okay. For example, question number 11. Wait, let's try out number 9. Okay? Just to reinforce what we have here. Number 9. We have another root. That means 6 minus 2x inside the root must be larger and equal to 0. You subtract 6 on both sides. Negative 2x is bigger equal to negative 6. You divide by 2, negative 2 divide by negative 2. When you divide by a negative number, you flip the sign. Okay, so x is smaller equal to positive 3. So if x is smaller than equal to positive 3, so 3 is there. And 3 is a bigger number, right? Bigger number is on the right, and the equal is a bracket. And then x is smaller than 3, so it's going all the way to the left. All the way to the left is negative infinity with parentheses. Now let's take a look at number 11. Number 11, we have a fraction. Actually, let me look at number 12. Number 12, we have a fraction. So whenever you have fraction, what's the basic thing of fraction? Fraction, the denominator cannot be 0. Okay, cannot be 0. So that means x can be any number, but the denominator cannot be 0. That means x cannot be 8. So basically, we have the situation as I demonstrated earlier. You can have all the number you want for x, starting with negative infinity, but going to the 8. Parentheses means skip 8, and then with a u, remember when you skip is a u, then start with u. Start with 8 again, going all the way to the right, which is positive infinity. So basically what this means is you have all the number for x besides the 8. 8 is not included and it's skipped. Okay, so that's that part. And the last question is number 19. So what I'm going to do is I'm going to demonstrate number 20. So in this each function, remember when we have the number inside the parentheses, that means the x is there, right? That means that number replaces x. However, when we have a compound function, number 20, when we have a compound function, we have two different criteria. We have, okay, that function is equivalent to this when x is smaller than 0. And that function is equivalent to that if x is bigger and equal to 0. So based on what number we want to plug it in, the function you use to solve it or evaluate it will be different. So the first one is negative 1. So negative 1 is actually smaller than 0, right? So smaller than 0 is the first criteria, and then we're going to use the first function equal to 4x minus 9 equal to 4, replace the x with negative 1 minus 9, get negative 4 minus 9 is negative 13. Pretty straightforward, huh? And the second function, you replace x with 0. Now, where is 0? 0 is not the first one. 0 is actually the second function because x is bigger equal to 0. So it belongs to the second category. Then we use the second function. So f 4x minus 18 equal 4 times 0 minus 18 give you negative 18. So those are pretty straightforward. You just have to look into which function you need to use based on the x criteria. All right, make sure you finish the rest of the problem that I assigned. Ignore the 3 and 4 from page 31. Make sure you turn them in, and I will collect them next class before the test to give you a quiz grade. Good luck.